Hello everyone, welcome to the pillars. In the last 2 or 3 classes, I have completed this second order linear homogeneous and non-homogeneous ordinary differential equations. I have discussed about the methods to find out both the complementary function and a particular integral. Now, today's class, we will take the differential equations which don't have constant coefficients, because I have taken the differential equations, both homogeneous and non-homogeneous. Those differential equations have had the constant coefficients, but in today's class we will take variable coefficients, specifically this Cauchy-Euler ordinary differential equation. Okay, so this is the there is a high probability you will get a question from this part. May it be IIT exam or NET or GATE or JEST, in any exam, there is higher probability that you will get a question from this part. And also the coming 1 or 2 classes will be very important, because they are not asking very simple questions nowadays. They are taking this Cauchy-Euler differential equation or Abel's theorem, that is to find the Wronskian, or they are asking the coupled ordinary differential equations, how to solve this coupled ordinary differential equations. Right, we will be talking about these very important parts in coming 2 classes and also in today's class. So just be focused, and in today's class there will be a lot of mathematics. So be focused. If you don't understand a simple mathematics in this part, so you can just rewind and watch it again. You will definitely get it. In case you don't get it, you can ask me in the comment section. You are always free to ask any question, any kind of doubt you are free to ask, or you can contact me through Gmail and Instagram. I always attach one of the things. Right, so let's go to the topic now. Now this Cauchy-Euler differential equation I will take in general case, that is the nth order Cauchy-Euler differential equation from, and after that we will see a definite case, that is the second order Cauchy-Euler ordinary differential equation. Right. So general form of this kind of ordinary differential equation are written as an x power n dny by dx power n plus, this goes on decreasing, like an minus 1 x power n minus 1 dn minus 1 y divided by dx n minus 1, and so on, like so on, till a1 x dy by dx plus a0 y is equal to f of x, any function of x. This can be a function of x or constant or 0, anything it can be, it doesn't matter. Now this an minus 1, a1, a0, all these things are constants, all the coefficients are constant. But if you see, with this an or a1 or an minus 1, there is x power n minus 1. That's why we are taking this, we are calling this that these don't have constant coefficients. Right, these are variables, these x are independent variables. Right, so what we can do in these cases, remember in this Cauchy-Euler differential equation, the power of x is the power of x and this order of differentiation is always same. These two are multiplied, so this n is always same here. This n minus 1, you can see these are same. The power of x and order of differentiation is always same. Now what we can do in these cases, we can make a suitable substitution. By making this suitable substitution, these variable coefficients are reduced to constant coefficients. After that, we can find the complementary function or particular integral, as I have already told in the previous classes. Okay, so now let's see what is this suitable substitution. Now let's put x is equal to e power t. This is the suitable substitution. If x is equal to e power t, then t becomes log x. Okay, so let's take a box here. This is important. Now if you see here, this one here, if you differentiate this with respect to x, then you will get dt by dx will be equal to 1 by x. right? Now our job is to reduce this dy by dx into dy by dt, because we have taken x as a function of t here. Okay, so now let's take dy by dx. dy by dx. You can write it down as dy by dt into dt by dx. It's as simple as that. Now dt by dx is 1 by x. You can put 1 by x dy by dt. Right? These are simple mathematics. I have already told you. Just keep your focus. Right? You will get in one time. Now take this x and multiply here. X dy by dx will be equal to dy by dt. If you take d by dt as capital D, it is the operator, then it will be capital D into y. Let's take, since capital D is equal to d by dt. Right? So x into dy by dx will be equal to capital D into y. So here we can substitute x into dy by dx as capital D into y. Right? Now this gets reduced. Let's take this d square by dx square. We are taking dy by dx and then d square y by dx square. Then similarly all the terms will be reduced. So now let's take d square y by dx square. So here what we can do, this will be d by dx into dy by dx, right? And here you got dy by dx as 1 by x into dy by dt. Now here take this and substitute here. You will get d by dt of 1 by x dy by dt. So this is x here. Just see where I am making mistakes, because this is very important mathematics, right? So here you can use this differentiation, that is product rule. In product rule, you keep this one term and take the derivative of this one, and then take this term and take the derivative of this one. Now you can do what you can do. D square y by dx square is equal to d by dx of dy by dt 1 by x as it is, then dy by dt d by dx of 1 by x. Right? We have done the simple product rule here. Now if you see, let's take this as another function. Let's take this as phi. Right? Then this will be d phi by dx. Right? I am taking this as phi. So taking this term here, d phi by dx. This we can write down d phi by dt and again dt by dx. Right? And this is, as you know, this is 1 by x here. dt by dx is 1 by x. So we can write down 1 by x d phi by dt. Now take this and substitute here. And the differentiation of 1 by x will be minus 1 by x square. Okay. So now let's write down. Keep this in mind. X into d by dx as capital D into y. I will be removing this one. Right. So you have to substitute here. Then you will get d square y by dx square is equal to, here d by dx of dy by dt, and here you can substitute in this place this one. Okay, and take this phi as dy by dt. So finally you will get d by dt of dy by dt. This is d phi by dt here. D phi by dt. D by dt is as it is, and phi is dy by dt. Right? with it there is 1 by x and here is another 1 by x. So this will give you 1 by x square. And the second term, if you differentiate 1 by x with respect to x, then this will give you minus 1 by x square. So here 1 by x square dy by dt. Right? Now here 1 by x square and here 1 by x square. So if you take this x square to LHS, you can write down x square d square y by dx square can be written as, here a double derivative of y with respect to t, d square y by dt square minus dy by dt. And we have taken this d by dt as operator capital D. That's why d square by dt square will be capital D square. So you can write this down as d square minus d of y. Since d by dt is capital D and d square by dt square is capital D square. Right? So what you got, let me summarize here. I will move in all these things so that I can summarize the two steps I have done. Okay. So what we got in first case, we got x dy by dx gives you capital D of y, then x square d square y by dx square is equal to d into d minus 1 of y. Similarly, if you proceed, x cube dx cube y by dx cube, sorry, d cube y by dx cube will be d into d minus 1 into d minus 2 of y. Right? So this process goes on and on. If you take here n, then this goes on till n minus 1. That is d minus n minus 1. Let me write it down here. For x power n, dny by dx power n will be d into d minus 1 into d minus 2, so on till d minus n minus 1 of y. Right? I think this part is clear. All these parts are clear. Now if you see, if you take the product of all these things, there is no variables associated with y. Here we have x into dy by dx. We substitute x into dy by dx as capital dy. Here if you put x dy by dx as capital dy, this will give you a1 capital D into y. Similarly, if we put x square d square y by dx square, this one, then there will be a2 into d into d minus y into y. So all the coefficients like x power n minus 1 that were associated with this ordinary differential equation, all the coefficients, variable coefficients, are now reduced. Right? So let me take a special case of here. Here I will take the second order Cauchy-Euler differential equation, because that is the most probable question you will get in the exam. They will not ask third order or fourth order, because that will be very complicated to calculate. They will most probably ask the second order Cauchy-Euler differential equation. So let me take this second order. Second order Cauchy-Euler ordinary differential equation. Right. So the form of this second order Cauchy-Euler differential equation will be a2 x square d square y by dx square plus a1 x dy by dx plus a0 y will be f of x. Remember, if this f of x will be is 0, then you just have to calculate this complementary function. And if this is some function of x, then I have already told you all the methods by which you can calculate the particular integral as well. Right? So I told you in these cases we make the suitable substitution, that is x is equal to e power t. That implies t becomes log x. Right? So all these all the equation or all the terms will be now reduced to d by dt or capital D term. So we can write down x square d square y by dx square will be a2 d into d minus 1 y plus a1 x into dy by dx is capital dy plus a naught y is equal to function of e to the power t, or we can take it some function of t. Right? So if you see here, I told you all these variables will be reduced. So if you see, there is no variable coefficients in this differential equation. There are only differentiation terms, it is d by dt. Right? So now if we simplify this one, this will be multiply here, this will be d square minus d, and so a2 d square y, a2 d square y, here minus a2d, here plus a1d. So finally you will get a1 minus a2 dy plus a0 y is equal to r of t. This is the general form of the second order Cauchy-Euler ordinary differential equation. Now if you see, in case of r of t or f of x is equal to 0, then you have to simply find out the complementary function, that is find out the roots, that is m value. Depending upon that you will get the complementary function. And if this RHS is not 0, some function of x, then you have to simply find out both the complementary function and particular integral. Right? So now let's take example. Let's take one example so that we get the whole thing what I am actually doing here. This is very simple, not that complicated if you see. Right? And there are very good questions based on this. I will do here 2 questions I will be doing. Let me take the first example. Okay. So this is the first example. Let me take another question. Okay. This is the first example. And the differential equation is given something like this: x square d square y by dx square minus x into dy by dx plus y is equal to log x. Right? So he is asked for the solution of this differential equation. Remember, whenever there is a differential equation is given, then just see if this is in this form. I've told you the general form. The power of this independent variable must be same as the order of the differentiation. If you see this equation, here there is x square, that is the power is 2, and there is second order differentiation of y with respect to x. Right? Here this is here power is 1 of x, then the differentiation is of first order. And here there is no x, that is power 0, there is no differentiation. So we can conclude that this is a second order Cauchy-Euler ordinary differential equation. So here we have to make the proper substitution, and this will be reduced to the ordinary differential equations with constant coefficients. Right? So I have already told what to substitute. You just put x dy by dx y as dy. Here d is d by dt. I am writing again and again, so don't confuse in any case. Right? D square y by dx square, that will be equal to d into d minus 1 into y. Right? So if you make this substitution, what we will get? This equation will be d into d minus 1 y minus d of y plus y is equal to log x. That is, we have put x is equal to e to the power t that implies t will be log x. So put log x as t, right? And now simplify or rearrange this. This will be d square y minus 2d, minus d here, minus d here. So this will be minus 2dy plus y is equal to t, right? So this is the reduced ordinary differential equation with constant coefficients. Now we have to solve this to find out the solution, both complementary function and particular integral. For complementary function, we have to take this RHS is equal to 0. By taking this 0, you will get the auxiliary equation. I am writing down AE, that is m square minus 2m plus 1 is equal to 0. This is m minus 1 whole square is equal to 0. So this will give m is equal to 1 and 1. And I told you, whenever there is the roots are equal and real, in that case you get YCF is equal to C1 plus C2 t. Here take t, by mistake don't take x, all the answer will be wrong, right? Because we have taken d by dt here. In this equation, this is d by dt, so you have to take t here, right? With this e to the power t. And we will substitute this value of t in the end. First let's find out the complementary function and particular integral, right? So for particular integral, this is the function of d here. We can write down yp is equal to 1 by d square minus 2d plus 1 of t. This is a first order polynomial. We have to use that method by taking the smallest power of d as common and converting all these things as infinite series of d. So for that I told you, take the lower order lower power of d as common. Here 1 is the lowest power, that is d power 0 here. So let's take that. 1 plus this whole term comes to this bracket, this one into t. Take this to numerator so that we use the binomial theorem and convert this to infinite series. 1 plus d square minus 2d whole power minus 1 into t. This will be 1 minus d square minus 2d of t. Because all the higher order, if you take, then this differentiation with t will be 0, right? So this will give you here 1 with t minus the second order differentiation will be 0. So we will only take 1 and 2d. Minus minus becomes plus, plus 2 into first derivative of t, that is 1 into 2. This is t plus 2. Now the final answer you will get here, don't lose focus. This is very important. Remember, you will definitely you will get one question from this part. So the final answer will be complementary function, that is C1 plus C2 into t e power t plus t plus 2. Now don't forget to substitute the value of t, right? So we have taken t as log x. If you put here, then the solution becomes y is equal to C1 plus C2 log x e power log x plus 2. And here e power log x, that will give you x. So the final answer is C1 plus C2 log x into x plus log x plus 2. This is the final answer. See, this is very simple, but just simple mathematics. You have to be strong in solving doing all the steps here, right? So let's take another example. This is very important example. Remember, this is very important from the point of view of IIT exam, JEST or GATE or CSIR net for competitive exams, maybe it PhD entrance exam or maybe MSc entrance exam. This is very, very important. If you understand this and solve this kind of problem, then your differential equation is clear. The whole differential equation is clear. Remember this. Okay. So let's take this example. This is very important. I am telling you again and again. This is second example. So the differential equation is given as y double dash plus 1 by z y dash minus m square by z square into y is equal to 0. And here is given m is equal to 0, 1, 2, so on. Okay. And he is given 4 statements. And I asked that which one of those are right. Let me write down first 4 sentence here. What are the statements? First statement P, that is z power m and z power minus m are 2 linear independent solutions for all values of m. For all values of m. Right. Then second statement is same. Z power m and z power minus m are 2 linear independent solutions for m greater than 0. Third one is 1 and log z are 2 linear independent solutions for m is equal to 0. And last one is z power m and log z are 2 linear independent solutions for all values of m. Right. So he has given options as option A is PRS, option B is PR, option C is QR, and the last option is SR. Now this is very fundamental. You have to do some analysis here. Now let's see the answer. So by looking at this differential equation, you must be nervous how to solve this. If you simply see this equation, there is the second order derivative of y with respect to z, because here z is the independent variable. Don't confuse or don't get traumatized to see all these things, right? So if you just multiply z square in the whole equation or take the LCM, you will simply see z square will be multiplied here, and here there is no multiplication, right? This will be z square y double dash plus z into y single dash minus m square y. If you do that, you will finally get z square y double dash plus z y dash minus m square y is equal to 0. And see this is the second order Cauchy-Euler differential equation with variable coefficients. Then we have to reduce this to constant coefficient of kind, and here RHS is 0, right? Then simply you have to substitute now. You have to put z is equal to e to the power t simply. That implies t will be log z. I have done the previous problem by taking x as the independent variable, but here z is the independent variable. So don't get nervous by doing all these things. Simply just stick to the basics, right? So here we will substitute in this case. This will be d into d minus 1 into y plus d into y minus m square y is equal to 0. Okay, so by simplifying, here d square y will be there, here minus dy plus dy, so this will be cancelled. Finally you will get d square minus m square into y is equal to 0, because here we will get minus dy and here plus dy, so both terms will be cancelled here and here, right? Then only d square y will be there and minus m square will be there. So this I have written here. And if you see, this is homogeneous differential equation, there is no need to find out the particular integral. If you do this, then simply find the complementary function to find out the roots. You will simply get d is equal to plus or minus m. Right? I am not taking this auxiliary equation by taking m because there is already m, so I am just keeping this as it is. You will get d is equal to plus or minus m, and you know how to find out the complementary function. I am not writing down complementary function CF as well because this is the only solution. Let me write it down here. Why CF? You will get definitely you will get confused here. Is equal to C1 e to the power m into z plus C2 e to the power minus mz. And by substituting the value of z here, I'm sorry, this is t, not z. I have done this mistake. Yeah. So t, because d by d we have taken this capital D, this is t, and we will substitute the value of t here. If you put the value of t, then C1 into e to the power m log z plus C2 e to the power minus m log z. And you know the property of logarithmic. This m here goes to here the power of z, and here minus m will go to the power of z. So it will be C1 e to the power log z power m plus C2 e to the power log z power minus m. And finally you will get C1 z power m plus C2 z power minus m. Let me write it down here and let's do some analysis. This is very interesting part. I enjoy this kind of questions because there is so many analysis to do. The answer you got, y is equal to C1 z power m plus C2 z power minus m. If you see here, you can simply say this m is given as 0, 1, 2, 3. This solution should be for all m. But that is wrong, definitely wrong. Because if you put m is equal to 0, then the differential equation we got here, t square minus m square into y is equal to 0, this will reduce to, by applying this, d square y is equal to 0. And when you find the roots, this will give you d is equal to 0 and 0. And the solution will be y is equal to C1 plus C2 into t e to the power 0. This will give you 1. So this is the answer. And t is log z. So finally you will get C1 plus C2 log z. And here you can conclude that for m is equal to 0, the two linear independent solutions for m is equal to 0, you saw here, this is constant and multiplication is with 1, C1 into 1 here and C2 into log z here. So the two linear independent solutions are 1 and log z. Concentrate. Two linear independent solutions are 1 and log z. Because here this is arbitrary constant, this is arbitrary constant. And in the multiplication there is the terms 1 and log z. So those will be linear independent solutions. So for particular m, that is m is equal to 0, these are the solutions we got. So in the option, there is 1 and log z are two linear independent solutions for m is equal to 0. So this is right. Okay, and the another solution is, and so this solution will be for what? That is m greater than 0, because for m is equal to 0, we got this one, 1 and log z. So, and m is given as 0, 1, 2, 3 like this. Okay, so for m is equal to 0, we got this one. That's why the rest of the m, this will be the answer. And this is for m is equal to 1, 2, 3, so on. That is m greater than 0. So this option is also right. So Q and R right, this is the answer. Right. So you see how much analysis I have done here. This is a very important question. These are the kind of questions you will be asked in the competitive exams. Right. Or in some interviews also they just give you situational problems like this. You have to just do the simple mathematics and find out the solutions and tell them. Right. So that's it for today's class. We will do Abel's theorem and the solution of coupled ordinary differential equation in the next class. In the last year just question, there was one question from coupled differential equations. I will do that problem also. So just keep your focus on these things. These are very important problems, and we will see in the next lecture. And go to my channel also. I have uploaded the lectures on Fourier series, and also some quantum mechanics concepts I will discuss there. Right. So see you in the next lecture. Stay home, stay safe. Bye bye.